Welcome to this last tutorial on Klayout. In this tutorial, we're gonna take a look at how to do hierarchical layouts. And so the idea is to make a ring oscillator by using our layout of the inverter as a building block. So as usual, we are gonna start Klayout. And we are starting the K layout in edit mode for the inverter cell. It's taking a little longer because I started the Docker from fresh, so I don't have anything in cache. There it is. K layout is finally opening. And here it is, the layout of our usual inverter. So at this point, what we're gonna do is we're gonna create a new cell. We're gonna call it ring or ring oscillator. And at this point, as you may have noticed, the ring has become the top cell. And what we're gonna do is we're gonna instantiate inside the layout of the ring oscillator, the inverter as a cell. Here, here is the inverter, and actually I measure earlier that my inverter is in the horizontal direction 3.69 microns. So what I'm gonna do, instead of instantiating the three inverter that I need by one, what I can do, I can here use this array instance feature and say that I want three columns of meaning three inverters basically, and that they should be spaced at a distance of 3.69 micron. And if I do this and then click, I should have my three inverter placed. And then if we go and increase the hierarchy level, we can see all the layers that are available. And as you see, we have three inverters back to back. And if you remember, the way that I built the inverter was on purpose done in such a way that basically the output of the first inverter gets automatically connected to the input of the second inverter. And similarly for the output of the second inverter gets automatically connected to the input of the third inverter. So what we need to do to build our ring oscillator at this point is just interconnect the input of the first inverter with the output of the last inverter. Before I go and I do this, I'm actually gonna go inside the inverter and making the inverter my new top layer. And what I'm wanna do, I wanna actually eliminate all the input and output ports of the inverters, and we will attach input and output ports only on the highest level of the hierarchy, which is the ring oscillator. So if we select the VDD and then use the shortcut Control X, we're gonna delete the VDD, same thing for the VSS, and then we're gonna try to do the same thing for the VI and the VO of the inverter. At this point, we go back and make the ring oscillator the new top layer. And as you see, all the input and output labels that we had, input and output ports label, have now disappeared. So at this point, if we want to make the last connection, what we need to do is to first make a couple of via one on the at the input port and one on the output port. So what we're gonna do is let's go here and hide the empty layer. We're gonna take the via layer, via one layer, and we are gonna draw a box kind of close to where we need to eventually place it. If I go and I select it, and then double click on it, and then we go on here, we see that actually the via are typically 0.26 by 0.26. So I'm gonna specify the dimension of the via. And so that's the correct dimension. Then I'm gonna do a Control C, Control V. Oops, that one. And we have now the two vias that we need to use it. Okay, let me make the window a little bit larger so I can and then select one of the via, and we are gonna move it, and we're gonna move it. Let me actually zoom and move it again, and we're gonna try to center it. So if we go here on with the rulers and we do a measure, we can see that, okay, it's a 0.055, and here is actually, so 0.007. Okay, so I'm gonna try to center, and so what I'm gonna do here, I select the via. I'm using the shortcut that corresponds to the open square parenthesis, and we are gonna move of 0.05 in the x direction, and actually also 0.05 in the y direction. Oh, actually, sorry, my bad. Let's redo it. I made a mistake. It was not, I should have not moved that by that much. So I'm gonna bring it back where it was and repeat the command. What I should have moved it was of 0.005. So let's redo this step. There it is. So now we can, the VI is centered, and I can double check it with the, maybe not actually. So I'm insisting it and redoing it. Need to bring it down. Let's just do the Y. There it is. So now here is, actually, let's see if measure edge. So 0.26, 0.26, and then actually let me erase to measure. Okay, so now it's 0.06, 0.06, 0.055, and 0.065. So actually, technically, I mean, doesn't really matter. I'm just getting obsessive here, but to show you what we need to do, we need to move this by 0.005 also in the x dimension. And there it is. And now, if you go measure, the via is centered. Okay, perfect. Okay, so now let's go and pick the other via and move it, and let's place it actually Let's zoom a little bit so it's easier to see what we're doing. We're gonna move the via. Okay, and let's place it here, and let's zoom all. I think that's now should be good enough. The last piece that we need is to place actually a layer 2 that connects the input and the output. So what I'm gonna do, I'm gonna pick the metal 2 layer. We're gonna do the connection using a path. So let's do that. Then let's zoom. Let's select and move. Let's zoom again. Okay, so let's align it on the edge. And let's zoom a little bit more again, and the metal 2. Then let's just go and make it a little bit wider, because 0.20 it's too small. We're gonna actually make it 0.3, and there it is. So now it's nicely centered across the metal. Then at this point, last step is I'm gonna click on partial and stretch the metal layer all the way up to the via 1 corresponding to the input of the ring oscillator. Perfect. So let me actually, before I do much more, let me do a DRC check and see if we have everything correct. Actually, that is running the wrong. DRC check is looking for density, so let me rerun it. We want to run the DRC on the main rules. There it is. Perfect. So we have no main DRC rule violations. So our ring oscillator is pretty much done. The last things that we should not forget to do is to bring back the labels. Actually, if we look here at the layers that I see, I don't have the metal 2 label. So let's make all the layers visible. Let's see, here is the metal 2 label. So we select it, and then we go on text, and we're gonna place maybe here the VDD. Let me click on it and change the name. Oops, I selected too many things. Okay. Change it from the default ABC to VDD. Then we're gonna place the VSS. And finally, we're gonna place the label V. Oops, and again selected too many things. Let's just here V out. Okay, perfect. Now the ring oscillator is complete. I'm just, for the sake of showing you that everything is okay, I'm gonna run again a DRC. And there it is. We passed DRC, no problem. And just to make sure that you're running the main DRC rules. So at this point, the last step is do not forget to save the name of your layout, because otherwise by default, we started as ring.gds. We will override the inverter. We want to change the name and become a ring.gds. So we go there, click save and OK, and that's it. Now we have our ring oscillator completely working. One last step which we actually need to do is to run layout versus schematic. So we need to check that the layout that we have just drawn match the desired schematic. To do this, the first step is to go and load some specific PDK options. And in particular, the PDK options we want to load are the ones that associated with LVS. And what I want to make sure is that I go and change the substrate name, because by default he has a certain name, but we have actually our substrate named VSS, so we should go and change it. And then the last step is to run the Klayout LVS. And if everything has run as expected, the LVS is successful. There it is. The layout and the schematic are perfectly matching. So at this point, what I'm gonna do is I'm gonna close it, exit the layout, and we have our layout of the ring oscillator finished. Before I stop with the tutorial, I want to actually show you a couple of under the hood things that go on when we do the LVS. The first thing is, well, clearly I already created earlier the schematic for the ring oscillator. So I'm going to use Xscheme to show you the schematic of the ring oscillator. And so here you see how the ring oscillator looks like. We have 3 inverters back to back, and then the output being connected back to the input of the output of the last inverter, back to the input of the first inverter. And then at this point, what you need to do is you need to generate a netlist for LVS. So if you go here in simulation and LVS, you click on LVS netlist plus top level is a subcircuit. And also you do need to remove this use spice prefix attribute. Then you click on netlist, and this is going to generate a ring dot spice netlist, which is what it has been used for comparing the netlist of the schematics to the netlist corresponding to the layout. So I'll go and quit it. And then the other thing that I'm just going to show you is that actually when you run the LVS with Klayout, what Klayout is doing is actually extracting a netlist out of the layout, and this is end up going into a file called ring extracted.cir, which I'm gonna open for you. And so here is the way that the layout, the netlist associated with the corresponding to the layout looks like. And then when you run the LVS makes a comparison between this ring extracted underscore CIR and let me open the ring dot spice that was generated through the schematics. And that's basically it. So that concludes this tutorial on how to do hierarchical layout.